This is Geometry, Section 5.1, Midsegments of a Triangle. So, what is a midsegment? A midsegment is in a triangle, and it's a segment that connects two midpoints together. So if we have two midpoints of two sides of a triangle and we connect those two midpoints with another segment, we call that a midsegment. So this is a example right here. So we've got triangle ABC, and this segment right here, XY, is a midsegment because X is the midpoint of AB and Y is the midpoint of AC. So we've got two midpoints connected by a segment. This is called a midsegment. So if XY is a midsegment, we've got two things that we know about it. We know that XY is parallel to BC. So a midsegment is always going to be parallel to the side of the triangle that it's not intersecting. So it intersects these two sides right here. It's going to be parallel to this side right here. It is also equal to half the length of that side that it's parallel to. So XY would be half of BC. If BC was 20 units long, XY would be 10 units long. So a few examples. The dotted lines are midsegments. We are given that. Include hash marks and find the values of the variables. So if this is a midsegment, that means this dot right here is a midpoint of this segment, this whole segment, this side of the triangle. So we can put hash marks here and here. We can also put hash marks here and here because this is also a midpoint right here. So it cuts this segment in half. So if this is congruent to this, then x has to be equal to this piece, so x has to be 5. If this is congruent to this, z has to be 9. To find y, we know that y is equal to half the length of the side that it's parallel to, so y is half of 12, which makes it 6. Same thing over here, so now we've got two midsegments. So we'll start with z. So z is connecting these two midpoints right here, which makes it parallel to 16, this side which is 16, and it also makes it half of 16. So z would be 8 units long. Here, x is half of this side right here, but it tells us that half of this side, so this is cut into half, half of this side is 5. The whole thing would be 10, so x is also just 5. For y, so if this is a midsegment, that means this is the midpoint. So if this piece is 7, y would also be 7. Here we are given that the midsegment here is 10. Then we're asked to find x, which is the side parallel to this midsegment of 10. Well, if the midsegment is half of x, then x would have to be 20 in order to make 10 half of it. So x has to be 20. This midsegment right here is 14, so this whole segment right here would have to be double that because the midsegment is half. So this would have to be 28, which would make z, which is really just half of this segment. That would make z also 14. So z is 14 for y. This piece right here is 34 units long. We know that this is a midpoint since we've got a midsegment right here. So since this is the midpoint, this piece has to be equal to this piece, so y is also 34. Here, let's start with x. So we've got a midsegment of 28. So each of these pieces would be equal to 28. So x would be 28 times 2, or 56. Y is a midsegment, so we take the side that it's parallel to and cut it in half. So half of 54 would be 27 for y. For z, we know that it's parallel to this side right here, and it's also going to be half of this side. Well, it tells us that half of this side right here is 19, so that's what z is, 19. Okay, we've got ST is a midsegment, TP is 14, so we'll label that. QR, this whole thing is 12, and SQ is 13. So we've got to find the perimeter of the whole triangle. So we know that this is a midsegment, which makes both of these midpoints. So if this is a midpoint, then this piece is congruent to this piece, so this piece is also 13. And this piece is congruent to this piece, so this piece is also 14. So if we add up all of these sides to find our perimeter, add up everything on the outside, if we add all of these numbers together, we get 66. So that's our perimeter. Perimeter of triangle PST. So PST is just this small triangle right here. We don't know yet what ST is, but we know ST is a midsegment, so it has to be half the length of this side which it's parallel to, so ST would have to be 6. So if we add up 14, 6, and 13, we get 33 for the perimeter. More examples, just a little bit more complicated. So we know that this is a midsegment right here. It says the dotted lines are midsegments. So we know that this piece has to equal half of the side that it's parallel to. So half of 38 would be 19. So 2x plus 3 has to be equal to 19. So now we just solve for x. We subtract 3. So 19 minus 3, 16 equals 2x. We divide both sides by 2. We get x equals 8. Over here, I know that these two pieces have to be congruent since this is a midpoint. So if 4y has to equal 20, to solve for y we just divide by 4. We figure out that y has to equal 5 in order for this piece to be congruent to this piece. Same thing over here. So now I've got a midsegment of 15 right here. So this piece right here has to be double what the midsegment is. Since the midsegment is half of this, each half of this would have to be 15, which makes the whole thing equal to 30. So now to solve for y, this 3y minus 9 has to equal 30. That's what this whole segment is. So I add 9. I get 39 equals 3y. I divide by 3, and I get that y equals 13. For x, x is right here. So I've got this and this. So I've got a midsegment here, and I've got the side that it's parallel to. So the midsegment is equal to half of this piece, but it's hard to figure out what half of 5x minus 4 is. So instead, I can say, all right, well, I know that this has to be 2x and this has to be 2x because each half of this is going to be equal to the midsegment. So this whole thing is really 4x, which is equal to this, because it says this whole segment is 5x minus 4, but I also know from the midsegment that this whole segment has to be equal to 2x plus 2x, which is 4x. So 5x minus 4 has to equal 4x. If I subtract 5x from both sides, I get negative x equals, if this is gone, I'm left with negative 4. So when I divide both sides by negative 1 to turn x positive, I get x equals positive 4. Last example, it says let H be the midpoint of AB. So A is here. Let's write out the coordinates of A. The coordinates are 9, 10. And the coordinates of B are 11, 2. So to find the midpoint, I've got to find the average of the x coordinates and the average of the y coordinates. So what number is halfway between 9 and 11? Well, 10 is halfway between 9 and 11. So I know the x coordinate is going to have to be 10. And what number is halfway between 10 and 2? So if I take the average of 10 and 2, 10 plus 2 divided by 2 gives me 12 over 2, which is 6. So that's the y coordinate. So 10, 6. This would be point H. It says H is the midpoint of AB. Let K be the midpoint of CB. So C, right here, the coordinates are 1, 4. And B, again, the coordinates are 11, 2. So the average of 1 and 11. So 1 and 11, if I add those together and divide by 2, I get 12 over 2 again, which is 6. So 6, you know, the x coordinate is going to be here. And the average of 4 and 2, well, halfway between 4 and 2 is 3. So the y coordinate's 3. So this is K. So this should be a midsegment, because we just found the two midpoints of these two sides of the triangle, and we connected them with a segment, so that should be a midsegment. So we're going to verify that the two things that we said about midsegments are true. So first verify that HK is parallel to AC. Well, we know that parallel lines have to have the same slope. So if I find the slope of HK, I'm going to count from K to H, so up 1, 2, 3 over 1, 2, 3, 4. So the slope would be rise over run, 3 over 4. From C all the way to A, that would be up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. So 6 over 8, which would also reduce to 3 over 4. So they have the same slope, which means they are parallel. So we verified that they're parallel. Now we have to verify that HK, the distance from H to K, or the length of HK, is equal to half the length of AC. So we need to use the distance formula to find both of those. So H and K, the coordinates for H and K are 10, 6, and 6, 3 from up here. So we're going to plug those into the distance formula. Difference of our x coordinates, so we've got 10 minus 6 squared plus 6 minus 3 squared. So that's going to equal 10 minus 6 is 4. 4 squared is 16. 6 minus 3 is 3. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. So HK is 5, which means half of AC should equal 5. So AC should equal 10. So that when we take half of it, we get 5. So let's figure that out. So A and C, coordinates of A are 9, 10. So 9, 10, and the coordinates of C are 1, 4. So if I plug these in the distance formula, difference of my x coordinates, 9 minus 1 squared, plus difference of the y coordinates, 10 minus 4 squared. So this is going to equal 9 minus 1, which is 8, squared, which is 64. 10 minus 4 is 6, squared is 36. 64 plus 36 is 100. Square root of 100 equals 10. So AC, if I take half of that, I do get 5, which is the length of HK. So both of these work. HK is half of AC, and HK was parallel to AC.